Today I'm going to go through the logarithms and exponentials question, which was question 9. Now this was answered beautifully by a few students, however I'm just going to go through how I would answer the question for those who weren't quite sure where to start. And the first thing to notice for that, this is a little bit different because we've been given a base of a, and quite often we're not normally exposed to that sort of question. So, log base a of 27 equals 3 plus log base a of 8. The first thing I'm going to do is collect my logs together so I can get rid of them somehow. So I'm going to take away log base a of 8 from both sides. That would leave me with log base a of 27. Take away log base a of 8 would equal 3. Thinking about my log laws when I'm subtracting them, I can write a division. So it would be log base a of 27 over 8 would be equal to 3. And now if I take everything to the power where a is the base, that's going to cancel out with a log, so I end up with 27 over 8, and that's going to be equal to a cubed. Once I'm at this stage, I'm just really rearranging to get what a is. Well, I know that from here, I know that a cubed is 27 over 8, so therefore a is going to be equal to the cube root of 27 over 8. And we should be pretty comfortable at this stage to just cube root the top and the bottom of the fraction separately, which would give me 3 over 2. So therefore my value of a is equal to 3 over 2. That would be the first 3 marks of this question. For the next part, it says solve the equation 2 to the power of x plus 3 equals 6 to the power of x take away 1. Now again, we have an issue where our bases aren't the same value. So what I'm going to do is just use the generic log so that I can get rid of the exponents in some way. So I'm going to do this working out in black. I'm going to scroll down a little bit and rewrite the question. So the question was 2 to the x minus 1. So 2 to the x plus 3 equals 6 to the x minus 1. Let me just check that's correct first of all. Perfect. And then what I'm going to do is take the generic log, so just log base 10 of 2 to the x plus 3 equals log base 10 of 6 to the x minus 1. Now, we know it's base 10, so I don't really need to write that base every time. But the reason I've taken the log is so that I can take the exponent to be the coefficient. So this leaves me with x plus 3 lots of log 2. And that equals x subtract 1 lots of log 6. I'm just going to rearrange and expand so that I get all my x's on one side and I get all my just values, my numbers, my logs on the other side. So this is going to give me, when I expand, I get x log 2 plus 3 log 2. I'm going to do this in one step. I'm going to just expand the other side as well, which will give me x log 6 take away log 6. From here, I'm going to take away x log 6. Sorry, I'm going to add log 6 and take away x log 2. So that gives me 3 log 2 add log 6 equals x log 6 take away x log 2. Factorising out my x is log 6 take away log 2, which would be equal to 3 log 2 plus log 6. And then dividing across, I get x equals 3 log 2 plus log 6 over log 6 minus log 2. You just type it on your calculator, you end up with an answer of 3.52, and that is to 3 significant figures.